So first of all, I wanted to say thank you so much to Radical Passive and Gosha Zaborsky for inviting me. And one of the things I wanted to say about Gosha, he was like one of my, I think, inspiring professor during the time when I studied at Belarusian National Technical University. And I think part of where I am right now is thankful to him because of his lectures and when he led the projects. So today I will speak about how and why to print shark skin on 3D printer and how to get such life. Okay, next one. And as the title suggests, I will talk about a little bit about me. I will talk about the 3D printed geometries and the textiles, and especially the shark skin, and also how to what I learned through this process of my career from the start till where I'm right now. So kind of about me, I'm interested in the designing across the scales. I started in Minsk from designing the urban master plans, then switched to the interior design. Then I was getting the degree, master degree in emerging technology and design, and right now I focused on the micron scale design. So basically, how I started from ceiling planks to the 3D printing. My first project that I was doing at the Shkolnikov atelier in Minsk, I was basically calculating the ceilings, how to put the tiles and everything. That was basically my first experience into architecture. And that small step by step led me to create something on the micron scale. So I will focus a couple of topic about the 3 countries that I've been living to. First, I will start in Minsk and selected the project that I the mostly interested in when I was doing it. That was in Minsk. It was a Viber office for the very fun creative company. The project was about 1,800 square meters, so it was quite large. And our goal was to take the essence of the company, since it's very dynamic team. It has to adapt to different situations. The team can start from 5 people to 15 people, and how the space can facilitate and adapt to the needs of the company. And I think a second part of the project was how to incorporate actually the branding and how to incorporate the colors of the company into the interior design. And this is where the Memphis style helped us, since in the 80s it was very fun. It connected different patterns and colors in the environment, and this is kind of we used as an inspiration to put it. Yeah, that's basically kind of overall of the design project. One of my favorite parts is to create the forum where people can use it for completely different occasions, from lectures to just meet each other, and organize those spontaneous places where people can meet and relax during the working time. Yeah, kind of about that. Then I will shift to basically after I finished working on the interior design, I had an opportunity to work on the pavilion scale while I was studying at the Architectural Association. So I've got the Champion Scholarship that allowed me to study there. And this is where the project that explored the curved folding of the metal techniques and the robotics. How can we make the very, very thin metal sheet very strong and not buckling, and create the shapes that can stand? And how basically to work with the very complex geometries. And during my master thesis, I was focusing on the several topics. Is kind of what can we do in the future when the urban development is changing, the temperatures is rising, and how the climatic and political changes are influencing the territory in the urban scale, and also at the natural scale, when you're working with the landscape and the city as a whole complex system. And also how can you, by small interventions, can control and see how it is influencing the big system on the urban scale. Yep, that was basically in Nicosia, Cyprus. I was exploring that territory between 2 countries of Turkey and the Greek part. Here was the project led me to explore how can we work with actually the flows of the city, and using the Bernoulli's principle, when you basically create the differentials of the pressure and can increase the flow, how can you circulate the air in the very arid environment and increasing temperatures? And also at the same time working with the shadow, because as far as we know that the shadow can decrease the temperature by 5 degrees Celsius, sometimes from 1 to 5 degrees Celsius, and how basically was exploring the curvature and at the same time the flow and geometries, how the different curvatures and different geometries can influence the flow in the city, and can we cool it down or can we not? And basically one of the main conclusions was from that the surface and the distance of the interventions can play a key role in the infrastructure and control the air movement. And also it also depends on the height of existing infrastructure, and the infrastructure that you're putting in can create different pressure zones and move the air for cool down. Yeah, and then I will move to the third opportunity when I moved to United States. I joined the MIT spin-off startup as a both role. Since the startup, I was working with helping with visualization, helping with the photography, and also as a computational designer. And I will talk a little bit about the company that I'm currently working. So OBT is a startup that is working with the soft good materials, and this is the first time when I can just show a small example. It's the first time that I saw that you can print something that is soft on a 3D printer, because before I saw only very, very rigid goods. And it's also included as a cross-disciplinary teams, where we're working with the polymer team and with the design team to make a different products. Yeah, this is actually concept is quite fairly new in the United States. Something that we're used in like post-Soviet countries, that we have institutions where we have all the specialists, I don't know, architects, engineers at one company. This is something very new for United States, especially in the startups where you can unite different teams in one building. And this is actually helping to streamline all the processes. So for instance, how PT is working, we have a polymer development team, we have computational design, we have virtual factory, and then everything is digitally controlled and can be sent to the production floor. So it's kind of like a new type of manufacturing company. And also to mention, this was one of the first in the world roll-to-roll 3D printing company. Roll-to-roll means, I think the easiest example, if you think about newspapers or when you print in magazines, you kind of have continuous belt that can create. So that's kind of very similar in this case. And the second thing is that's very interesting is at OPT, we're designing materials across the scales. And as you can see on the slide, like this is the 3D printed at like 1 millimeter. And we can print down to 50 microns, which is like human hair, because like human hair is 70 microns, and it's basically around that time. So we basically can print the hair. I will talk a little bit about how design process is working for the 3D printing company. So first, we can control the freeform fibers. So basically we design it in the very, very tiny fiber scale. We can change the shape of it, we can change the diameter of it. Then we're thinking at the unit scale, how big we can print and which qualities it can give us. And then we are moving to assemble, which you're basically creating the final product. And a little bit about technology. So as far as you know, there is like several types of 3D printing. At OPT, we're using the photopolymerization. Is basically when you have a liquid resin, and then by projecting the image, you can cure the resin, and this is becoming a solid. This is how it's basically from liquid to solid object. Yes, that's. And moving to the shark skin, basically how I was 3D printing and everything. I will present, this is like it's a 3 days project that I was doing during the hackathon. Sometimes in the company we create in 3 days where you can just explore different ideas, and I will share with you these 3 days of work with you. So why am I doing it? First of all, I was very interested to explore what can we do in terms of performative textiles, and how can we control the geometries of the textiles to create different features for it. And second interesting part for me is to apply the knowledge that I've obtained during my master's studies in computational fluid dynamics and apply it to the material scale, and see how the simulations can help us with the textiles. And kind of shark skin is actually, when I explored it, it divided into topics. So first of all is the shark skin. It was interesting was shark skin densical geometry, and what is the benefits of it can be in the human world. It has a very great drag reduction. It has great water weakening properties and have very good antimicrobial properties. So that can be used in the medical field. It can be used in other fields. And the second thing, what is very interesting in nature, is growth patterning. So all the denticles or even the feathers in chicken are not grown in a uniform way. You kind of scientists describe this right now as lecturian-like systems, when you have inhibitors and activators, and when you have a first row where the denticles started to grow, and then it's slowly populating the denticles across, and it helps to create the coverage and also the properties of the skin. So as I mentioned before, how this works, the partnering is derived from the dorsitail initiator row is basically the spine of the shark, and it grows surrounding appendages through the activators and inhibitors. And various activators and inhibitors can promote the denticles, and this is very good for interested to explore in the functional textiles. And the second thing that I learned, very interesting, that it depends on the shark geometries on the global scale. You can see that geometry is changing. Depends on where it is, next to the head, in the middle of the body, and the tail, and the distances between the denticles and everything is controlling the drags and reduction, and help the shark skin to move through the water. And on the micron scale of how the denticles are working is in how it is shaped. Is basically very small tooth-like dermal denticles that protrude from the flexible epidermis. And typically the size of this denticle is from 0.1 millimeter to 1 millimeter width. So the question was how to translate it into the computational world, and what can we explore. So I extracted several parameters that can be done from it. It was the denticle of the crown, the height, the neck width, the base of the base width, and the distance between the rims and the height of the rims. That's basically the basic parameters that can relate to print and explore what is actually influencing what in fluids. And the second question was how to translate the natural patterning of the skin into the computational system. There are several ways that can be done. At this moment, I was exploring the cellular automata system. Is basically when you have an activator inhibitor growth patterning system of the cells. You're dividing it by number of cells, and then you're assigning to where you have activators, and when you have inhibitors, and then different position of the cell will create different patterns. And this can be created as a great tool for the future textiles in the company. So basically combining both. So on the left, you see I was exploring how can we create digitally different patterning and create it more and make it more automotive compared to just sketching it. And it's valued when you're doing the computational design models for the 3D printing. And the second thing, I extracted the different density and different tooth angles to print and see where it can go. So exporting all of these parameters I'm kind of it's an example of what OPT is capable of. Basically, want to next is a 3D print and by selecting the parameters that I already chose and see how it can actually affect. And using the very, very powerful technology of OPT industries. This is kind of similar materials that I was looking at the micron scale that we already produced and how it can be combined together. And also wanted to mention that you can see kind of in action that these materials, this was a topic of exploring the space fabrics, since in current production it's very, very hard to do the space fabrics which are used in the car production, in the seats, how it can be a single uniform material that can be done as a one process, not 50 different processes. And I kind of wanted to let into lessons I learned and continue to learn through all of this process when I was moving to different countries and having different educational experience. So first of all, my lesson was working in the multicultural environments, and actually quality in different countries means completely different things. And this is what I mostly faced very difficulty working in the United States, because for them, quality means the shortest way between the problem and solution. Trial and error until somebody will get it right. And also quality versus quantity. In the States kind of used to create a lot and then see what happens, rather than thinking first and then having only one result. So I was calling it myself, as I think in our culture we have this phrase, 7 times measure, 1 time cut. So here I had to learn how to do 7 times measure and 1 time cut. This is basically also, there is no way, like in Europe, you're doing the discussion first and then you agree what you as a collective are doing. It's kind of a collective is becoming a proposal of individuals, and then from proposal of individuals is decided what the collective is going to do. This was to me was something very, very new and different to work in such environment. And also one was a very interesting example of teaching in the multicultural environment when you need to think how to behave in a culture that you never grew up. Once it was a case when the student was presenting his project, and since if you know the American cities are very, very segregated, and it's based on the income level, based on the housing that you are living, and the student was proposing the project where it was like about the future of the city, and he was proposing that there is a different levels of the top floor where everyone have an access to the park, and then there's a bottom floor where people are repurposing the different bus schools into the housing. And this is when I did not know how to respond, because this is completely out of what I learned in my culture, and I did not know how to respond to that. So that was very interesting. How do you teach in China, or how do you teach in Japan when you grow up in different rules? And the second thing that I learned that helped me to work on a different scales and different companies is something that I think architectural education is providing, and it has like very nice transferable skills, because it's mostly education is based on the project and it's problem learning educational system. When you're doing research of the problem, you're looking at different case studies, you're coming up with different ideas, you're iterating, and then you're presenting. So this is something that not every education has, and I think it's really, really valuable to other fields when architects are interested in. And this is something that I wanted to share to you as some of the resources that helped me, because I think a lot of people right now are moving to other countries, have to adapt to different cultural systems, to different ways of behavior. And these 2 books of Cultural Map, Breaking Through the Invisible Boundaries of Global Business, and Writing the Cultural Waves. This is 2 books that really helped me to get through some issues, or actually understand how the system to work to accept it. Yeah. And the last one, I just wanted to conclude with a phrase: you never know where your experience will lead, so take all of them. Yeah, and interested about what is your path. Thank you.